Okay, I'm back and I've just flipped my paper over, so all the stuff that we just did, you can see there. The next topology we're going to talk about is going to be ring, and unbelievably, it looks like a ring. Everybody's being loud upstairs. I apologize for that. All right, so ring. Hang on. If we went back to this, and I took a wire, I took this terminator off, and I took this terminator off, and I connected a wire that went around like that, we just made a ring. So ring is just a bus network that's been looped back on itself. And when I started at Lakeland, we had a ring, which usually it uses token passing. So usually it's called token ring. So when we talk about ring, we're almost always talking about token ring. So token ring networks were a little bit different. The way things worked, things still flood, but they flood in a slightly different way. So in this, if you think of a tube that runs around and kind of stops and then goes and stops and goes and stops, that's how this works. Okay, so there actually is a flow direction. So it goes from A to B and B to C and C to D and D to E and E to F and then F to A, and it just rotates that way. Now, the way that this works with token passing, and I'm very visual, so again, getting ready for certifications, I'm trying to figure out how this works and how I can differentiate this. A token in this, it's not actually true, but in my mind, this is how I think about it. When you go to the bank and you go to the drive-through, and they have that carrier, that tube that you put all of your stuff in, and you close it up, and then you put it, and it sucks it up the tube. That is, in my mind, what the token is. So a token, when we do token passing, when the network initiates, we actually have a token master that is elected, and we don't need to know why or how. But let's say that A is the token master. He is the king. That's a terrible crown. But A is the token master. A will create a brand new token and will send it downstream. Now, everything is going to go downstream. So everything is going to go in this direction. It's going to go out and around. A creates a token as the token master, creates the token, and sends it empty downstream. Now, B takes that, receives that token. If B wants to talk, B will put whatever packet it wants inside that token and send it downstream. So let's say in this case, B wants to talk to E. Okay, so B takes the message and puts it in the token and sends it, and it comes down to C, and C gets it. Now, these are active clients. C looks at it and says, oh, this is actually for E, it's not for me. But it will regenerate the message and will send it downstream to D. D looks at it, nope, it's not for me, sends it downstream. E says, hey, this is for me. And actually there's a binary flag, there's a bit, which is a flag on that token. E will read it and then will flip that flag so that it's marked as received. And then we'll regenerate that token, send it to F. F will regenerate that token, send it to A. A will regenerate that token and send it downstream to B. Now, B started it. So B sends the message, E gets it, flags it that it's been received, comes back around, and B gets his own message back. Now, there's a couple things. B knows that it was sent successfully because he got the message back and it's had the flag tripped. So he knows that E has read it, and so this is delivery confirmation. We got delivery confirmation from B to E. Hasn't done anything with it yet. I don't know what his answer is. All he did was flag it that he'd received it. But yes, E did receive the message and it came all the way back around. Now, at that point, that cycle is done. B then will kill that packet, destroy that packet, create a brand new clean empty packet, and send it downstream to C. And if C wants to talk, let's say C wants to send a message to F. It'll go down to F, it'll flag, it'll come back to C. Then C will destroy that token and then create a brand new empty one, which will get passed to D. Now, if everybody in this ring wants to talk, this is a very, very fair way of doing it. Everybody gets a fair chance. Let's say that B wants to continually talk. B has to give C a chance, C gives D a chance, D gives E a chance, F gets a chance, A gets a chance, then it comes back around to B. So remember the Ethernet at about 50 it drops off? Well, for Token Ring, it looks like that. So at 40,000 users on your network, you're still getting almost 100% capacity. So early on, when you're talking about bus versus ring or bus versus token ring, Ethernet bus versus token ring, it wasn't even really a fair game because this handled traffic so much better. You could have 40,000 users, and the token is essentially traveling at the speed of light. So, you're making thousands and thousands of revolutions around this ring per second. Now, one of the issues that we have with Ring, what happens if there's a break? Well, if there is a break, then we have a problem. We have an unterminated network, and everything's going to stop. This is the point. I have a Dilbert that I physically. I'm going to write Dilbert. I have a Dilbert cartoon about this. Oddly enough, I just wrote Dilbert right there. So I'm going to remember at the beginning of the next video, I'll actually dig that out and I'll show you that Dilbert. We got a break and the network goes down. Now, with bus, when the network went down, there's nothing to tell us where the break is. We don't know. It could be anything, anywhere. In this case, whenever the network goes down for any reason, there's a process called beaconing. Yep. Wrote on myself. Beaconing. I kind of miss the whiteboard where you can erase things because I can't erase here. I bought some really cheap whiteboards, but they were dollar store whiteboards, and I don't think I want to try them. I'm going to still use it. I'm going to order some nice ones, but I'm just using paper until then. So at some point, very soon, I will have a whiteboard that I can draw on. We'll see if it works the same way as it does in the classroom. Anyway, back to beaconing. So beaconing is a help something's wrong message, and every machine is configured to beacon if they have not heard from their upstream neighbor. So upstream. If you haven't heard from your upstream neighbor in 2 seconds, I believe it's 2 seconds. If you haven't heard from your upstream neighbor in 2 seconds, now in 2 seconds, remember there should be maybe 100,000 revolutions. I should have seen 100,000 packets in 2 seconds. So if 2 seconds goes by and I haven't seen any tokens, there's a real problem. And so the machine will start to beacon. And a beacon it's a special token. It's kind of an emergency token. So the machine will create this emergency token and send it downstream. And it will continue to do that until it hears from its upstream neighbor. Okay. So let's say we got a break here. Immediately, E, F, A, B, C, and D all start to beacon. So they all start generating special tokens and sending them downstream. Now, let's see what happens. So D generates that beacon and sends it downstream. C generates the same type of beacon and the beacon just says, hey, I'm D and I'm not getting anything from my upstream neighbor. Hey, I'm C and I'm not getting anything from my upstream neighbor. But when C puts that beacon out, D gets it, and D says, oh, I just got something from my upstream neighbor, and it'll stop beaconing. So D gets C gets one from B gets one from A gets one from F gets one from E, so all of these guys shut up. And the only guy left beaconing is E. So there's a break in the network goes down. I do have to log in, and I have to open up a packet capture and I have to check, and everything on that network is just E beaconing. Help, I'm E and I can't hear from my upstream neighbor. Now, here's the question. If E can't hear from his upstream neighbor, what's the issue? Well, the inbound connection is disconnected. There's a break in this wire. The outbound connection from here is disconnected. Let's say I have 40,000 machines on my network, and I know the break is somewhere right there between this machine and that machine. So I only have to check the connection on this end, the connection on that end, and the wire in between. That's it. I know the break is in that bubble somewhere. Now, was it super easy to figure out? I had to log into a machine and do a packet capture and figure out the MAC address of that machine, which doesn't mean anything to us now, possibly, but at the address, I had to find who was talking. And when I said, the E is talking, and E can't hear from its upstream neighbor, and I know this is the way it goes. So the upstream neighbor for E is D, and so those are the two machines, and the break's got to be somewhere in that range. So way, way, way better than bus, because bus was just nightmarish. Okay, so let's see if I got all these. So ring, single continuous loop of wire. Yep. Best handling of network traffic. Got it. Communication allowed via token and the token passing scheme. Did that. Breaking a wire takes the whole network down. Yep. We do get beaconing. Moderately difficult to troubleshoot, but only because I have to log in and I have to actually do a packet capture and understand the physical arrangement of my network to know how everything's wired up. Whoa, the camera just freaked out. And my clients are active because they're taking the message inbound, they're looking at it, and whether it belongs to them or not, they're repeating it and sending it on. Okay. I think we got that. So we know that ring is better than bus, because bus, just that right there. I mean, when I was going through this originally, I'm like, oh my gosh, if anything goes wrong, we got to look everywhere for anything, and anything that goes wrong will take the whole network out. Okay, so with ring, actually, I could have a problem with ring because if I disconnected F, the network's going to go down. If I disconnect F, this essentially is an unconnected, unterminated network, usually. And so the break would essentially be here and A would be beaconing. And then I would know, well, F doesn't exist, so the next upstream neighbor is going to be E. So the break is somewhere between E and A. At least I've limited it down to 2 machines, or in this case, kind of 2.5 machines because one's missing. But I know what the issue is. And if I know, F's missing, we plug it back in. There we go. Okay. So in my mind, ring is infinitely better than bus, just primarily because of that. Well, because of that, and because of this bus Ethernet drops off and then token ring goes on essentially forever. I can have a network as large as I want. I'm never going to have 40,000 users on a network. Never. And even Microsoft recommended not having more than 10,000. Even though you potentially could do that the physical administration of 10,000 user accounts or 10,000 machine accounts actually was too much to handle for the security database at that time, the SAM database. And so they recommended that not more than 10,000. That's actually, the limitation of that's kind of gone away, but just the logistics of taking care of that many machines in one security apparatus is usually a little bit overwhelming. So typically we don't do it. All right. So the next one, 14 minutes, good. All right, so the next one is star, and I'll flip back over here. So star, and we will always talk about star Ethernet. And whenever we say Ethernet, we know that's CSMA CD. Oh, carrier sense multiple access with collision detection. When I was studying for the Net Plus, I got I don't know why, but there were some questions about like which of the following is Ethernet, and it was just a scramble of letters like CD, SM, AC, and you had to know what the acronym actually was. So this one's really stupid. I wrote a joke. Why did Ma cross the road? the road. Why did Ma cross the road? 'Cause Ma could. Really super stupid, but I never got that wrong. Everyone that I got on that, I remember the why did Ma cross the road? 'Cause Ma could, and I got them all in the right order. So, stupid helps out sometimes. All right, so that was not what we were supposed to be doing here. We're not telling really bad dad jokes for our certification prospects. Okay, so Star Ethernet is 99 point whatever percent of what you're going to see today. It's going to have a device. Now I'm going to put a hub here. Typically it's going to be a switch. We don't know the difference logistically yet between a switch and a hub. So right now we'll say they're the same. And I'll even do, today it's going to be a hub, but technically it could be, today it's going to be a switch, but it technically could be a hub. So this is a device that has multiple ports, and I'll put 3 ports out of the top and 3 ports out of the bottom, although typically all the ports are on one side. But I want to do A, B, and C, and D, E, and F. So A, B, and C are connected there, and D, E, and F are connected here. All right, so Star uses the most wire. So in bus, we had, hang on, it's getting complicated here. In bus, we had a very short line that just connected from one end to the other. In ring, we went all the way around the network and looped back on itself. So in the classroom, normally in the classroom, we have 3 rows in the classroom, and we would go this way, and then we connect across and go that way, and we connect across and go this way and end. So bus would just be zip, zip, zip. If we were doing ring, we would bring this around or around that way and close that off, and now we've got a full ring that wraps around. Okay, so in Star, we would have, and this is physically how we had it, we had a switch that sat here, and to machine 1, and to machine 2, and to machine 3, and to machine 4, and to machine 5, and machine 6, and then the next row. I mean, you can see we're just using an ungodly amount of wire, because I have to have a wire that goes from the main connectivity device to every other machine. So way more wire. Now, here's the thing. Our wire typically is going to be Cat 5e or Cat 6. We're still using 5e. It still does gigabit. So LAN infrastructure, 5e is still good. If we were in the classroom, we'd actually terminate cable. We'll watch a couple of videos on terminating cable. That's one of my favorite labs to do, is where we actually physically terminate cable. I've got a set of all the stuff here, so I'll probably do a demo. It'd be better than watching a video. I'll give you a demo and kind of walk you through it and show you what, we'll do that. So I have a Dilbert cartoon and termination I have to do. Writing myself little notes here that I will forget about and never, ever read again. So anyway, tons of wire, but we'll have 1,000-foot box of Cat 5e. Typically is going to be $50 to $70. So wire is the least of our concerns when we're doing this. If I can do this and it's going to cost, typically you're going to eat a box regardless. And this, so we need 1,200 feet of cable to do this. It's going to eat 2 boxes up. So it's $120, $150. We get really, really nice cable. It's going to be $200. So in an infrastructure implementation like this, labor is going to be like $10,000. So, if you got a $10,000 labor cost for installing, nobody's going to quibble about an extra $50. So typically the cable is the least expensive part of the whole thing. And so having, people say, oh my God, that's so much more cable. Yeah, but cable is nothing. Even if you went to 3 boxes, you're at $300. That really doesn't impact the total cost of the job. And especially if you're doing, for me, I had 24 machines at $500 a piece. having a third box of cable is inconsequential in the big picture. Even in the detail of it, it's inconsequential. Someone is taking shoes off right above my head, it sounds like. So hopefully you didn't hear that, but someone came in and stomped around. All right, back to Star Ethernet. So I've got a connectivity device here in the middle, and we'll do a whole section. I'll have a couple lectures probably on devices that we'll go through. So all of these are directly connected, and they all come in and they're connected to a back plane, which we will talk about more later. So internally, forgot about D, E, and F. So we got our connectivity device, and so if A sends a message, it comes in and it actually gets duplicated, and then it gets sent out every other connection other than the one that it came in. So A sends a message, it gets regenerated and sent to everybody else. This works in a lot of ways like bus, because it's these are all passive clients. They do not repeat anything. So if B gets it and A is sending a message to D and B gets it, B's not going to regenerate it and send it to B. This says, hey, it's kind of a cruel world in Ethernet. If you're there to get it, fine. If you're not, then we don't really care about you. So if A is sending a message to D, floods everywhere, everybody else just drops a message, but D gets it and then might respond to it. Might not, but and we don't know. A gets no confirmation. That was one of the great things about Ring. We actually got confirmation when it went around. E actually toggled the flag, and so B got delivery confirmation and knew that they'd received it. In Ethernet, you get no delivery confirmation. The only way you get delivery confirmation is when D responds to your message. In a lot of ways, that's like email. You send out an email. I don't know if you read it. The only time I know when you read it is when you respond to my email. So it's the same kind of thing that we're used to normally on our communication channels. Now, if let's say we get a break in the network. Let's say we get a break here. So there is no signal bounce. We don't need terminators anywhere. If any of these wires gets unplugged, or we get a cable break there, we get a cable break right there on E's line. So we come in the morning and E calls and says, hey, I don't have internet. My machine can't connect to the network. And I go, hey, D, are you okay? Yep. F, are you okay? Yep. Guess what? Problem is yours. This actually isn't, but this. This is one of our error messages that we have. Problem exists between keyboard and chair, PEBCAC. So we talk about it when something's a PEBCAC error. We also have a 1D10T error. So idiot. But people can figure 1D10T out, but very few people know what PEBCAC actually stands for. So when a lot of times we have users have PEBCAC problems, and we'll have, I don't know why I did it. Well, you shot yourself in the foot there because you did it to yourself. It's actually a user problem, and not in this case, it's a physical problem. But anyway, PEBCAC, one of the glorious things you learned today, if you didn't already know that. All right, so this break actually takes this user out. So the only thing that's going to take everybody out is if this connectivity device goes down. And it's pretty simple. If that connectivity device goes down, everybody's down. And that's the only thing that can do it. So after I started, I think I've been teaching for 6 months or something. I used to work in the city, and they called and said, hey, the network's out. And I said, what do you mean the network's out? Do you mean everybody's out or just one person's out? I said, the whole network's out. Nobody has connectivity. And I said, what's the switch? Switch is out. And like, how do you know? I'm like, well, that's the way this works. That's that's it. And they're like, well, no, that's not the issue. I'm like, okay, well, how do you know? Well, I said, physically go back and check. And we had it was in a back room with a server, and I had taken, because we didn't have a lot of money for it, I'd taken a switch and I'd put it in an old kitchen cabinet and mounted it. So it looked nice. Hung a kitchen cabinet on the wall, and then there was a shelf, and it had the switch, and all the wires came out of the ceiling. I think it was drop ceiling, so the cabinet was all the way up against the ceiling, and the wires all came out of the ceiling and hooked into the switch. And then on the bottom shelf of that was the power switch that or the surge protector that everything plugged into. And so I can hear, go check the switch. I don't want to check. Just go check the switch. I know it's the switch. So I hear footsteps. And then, click. And I heard I said, so what was it? Oh, well, I forgot that last night there was going to be an electrical storm, and somebody went around and switched all the surge protectors off, and then went back around and turned them all on this morning, but that one was inside a cabinet and they forgot to turn it back on. I said, well, that's, with the Star Ethernet network, it's easy. If everybody's down, it's the switch. Now, that being said, there is an issue with this being the central core, and if this goes out. So if you're in a situation where you only have one switch and that switch dies, you are down, which is typically why in a situation where I have this, I'm probably going to have two switches. I'm either going to have one just as a redundant empty, or I'm going to have one that's half loaded. So if I have 25 clients, I may have, let's say I have 18 clients. I'll have two 24-port switches, and I'll have part of them on one and part of them another, and the two switches cross-connected. And then if a switch goes out, I've got another one I can just move everybody over and everybody's back up and going. Otherwise, I risk the chance of the switch going down and the whole network being down. So, what can I tolerate? Can we tolerate 3 days of being down until I can order a new one, or do I need to have one on hand? If so, you have a box with a new one sitting right there, or, you have one already in the rack ready to go and we're partially using it. So, and switches, they don't last forever, but for technology, electrical equipment, I have switches that, was that 2004, 2006, probably 2004. All the switches in my lab have been running 24/7 basically since 2004 or 5, somewhere around there. So 15 years, and they have an actual lifespan of who knows how long, but usually they're people would say between 5 and 10 years. Usually you want to, and we probably should have switched out the switches. We probably should have replaced the switches by now. If we were an enterprise, I would have, you want to take them out before they fail. So usually after 10 years, probably like, hey, we probably need to upgrade those anyway. They're gigabit. So, probably at this point, if I was enterprise, I'd be wanting to go to 10 gig, or I want to have fiber uplinks in them. So usually on that kind of thing, between 5 and 10 years, we're probably replacing them anyway, because we're upgrading the technology. But they can, there's almost no moving parts on it. They just last forever. And unless you short them out or they get struck by lightning or something, they probably are going to last pretty much forever. They're probably going to last, for me, I'm going to retire before those things get taken out. And probably as soon as I retire, they'll just come in and unplug everything, because I don't know what to do with any of it. All right, let's go to the notes. Multiple wires radiating from a central hub or switch. A hub there, not in a device, but as in a spoke and hub type thing. Breaking one wire takes a single client down. So that's, once I saw that, I keep forgetting that once I saw that, this said to me, that beaconing made it much better than bus. And that, when Bob calls in and says he doesn't have connectivity to the network, but everybody else does, I know what the problem is. It's somewhere between the switch and Bob. Hey, Bob, can you look down and see, is there a cable kind of just, maybe it's a blue cable or a gray cable that's just laying on the floor, not plugged into anything? Oh, yeah, there is. Does it have kind of a clear end on it with a little clip? Yep. Can you plug that back into the machine then? Hey, the network's back up. There we go. So just ridiculously easy to troubleshoot. And, a I don't want to say dumb user because that's kind of redundant, but a user can take the entire network out by just unplugging their machine. A user can take the whole network out by unplugging their machine or breaking a cable or doing something else that they shouldn't do. Here, they just take themselves out. So, I thought that's really great. You can only do damage to yourself. So, 99 point whatever percent of everything you're going to do is going to be Star Ethernet, CSMA, CD, and this is what you're going to deal with. And you really can't get the other equipment anymore. So, I mean, everything that we have is going to be an Ethernet NIC, and all the equipment that you're going to see is going to fall into this. So, one of the questions is, if we don't have any equipment anyway, why are we even talking about the other two? Well, because of the logical versus physical, you're still going to see those. You still have to understand them because we still have a lot of things that logically work that way. We just don't physically have those as normal networks. We'll also have hybrid, which will be combinations of. When we talk about bridges, we'll talk about that. So I'm connecting. Usually, you would see that as I got a really old token ring network, and I have a new star, and I want to bridge between the two. I want to connect the two. We would call that a hybrid, two different ones connected by a bridge. And when we talk about bridges, we'll talk about that more. All right, mesh. The last one is mesh, and mesh is, I am running out of space on my piece. I'll just start a new piece. All right. So mesh, I'll just do 4 here. So we have a direct connection between every machine. All right. So we had an E. We had an F. We had a G. Oh, by the way, each one of these wires actually requires a NIC at either end. So, I mean, it would either be a NIC or I got 5 wires in here now, so I would need, we can buy double-headed NICs, and I think you can get quads. I know you can do doubles because we get them in servers a lot. So I would need 3 different network cards, each double-headed here. Add a G. We say, oh, by the way, hey, we're gonna add 5 more machines to the network. Okay, this is unusable. Now, the good thing about mesh is there's a direct connection, and let me go back to something that's not ridiculous. Okay, A, B, C, and D, there's a direct connection between each of them. If for some reason this wire gets broken or cut, I can still go to B and down, or to D and across. So I still have the way to do that. You will rarely, the only mesh that you'll see is usually between the high capacity devices in your data center. You'll have these. So our servers will come with 2 NICs that are double-headed. We'll come with a NIC that's double-headed, and sometimes 2, and it's to facilitate this direct connection. So you might have every server is directly connected to the backup device, or every server, the 3 main servers are actually directly connected to each other. And so if I lose a cable, I can still communicate because I can route through another machine. Typically, we won't see, this is called a full mesh. And this is pretty rare. I mean, it's only 3 or 4 machines. Once we get beyond that, it becomes just, we're buying NICs by the pallet load, and we're having gigantic cases so we can just have network cards in there. It becomes kind of ridiculous. So usually we'll have a partial mesh. So you'll have some of that, and everybody will be connected to 2 other, which is actually what the internet is. Most of the major nodes on the internet have at least 2 connections, sometimes 3 connections, and it's for this same thing. So if we had A, B, C, D, E, and F, and you would have something like that. Does everybody have? Yeah, everybody has at least 3 connections. And so any single wire can go down, and I can still get wherever I need to go. And that's essentially what the nodes on the internet actually do. So this partial mesh actually gets used way more. You'll rarely see a full mesh. But Mesh is easy. There's only actually one question where the answer is mesh, and it is, which of the topologies uses the most wire and network cards? Mesh. Every other one uses a single connection, single NIC. Mesh is the only one that actually has more than one physical connection to the other machines. Everything else, just a single connection. So, not used normally. Routers on the internet use it. Everybody's connected. A full mesh would give you full redundancy, so all of the wires, but you need one single path between you and the destination. Everything else can go away. Use an incredible amount of wire and network cards. I should add that to it, but I haven't. All right, so the questions that you will get, I'm pointing up there instead of down here. I keep forgetting. The one that I'm looking at is actually my preview screen, and I'm pointing at the wrong one again. Eventually, by the end of this class, I'm going to figure out actually how to teach online. Okay, so some questions that we would get. Let me move this up if I can. Drag this down. All right, so we know that mesh is uses the most wire and network cards, so I'm going to ignore that. So the other ones, which of the topologies, when a single wire breaks, takes the whole network down? That's bus and ring. Which ones use CSMACD? That's Ethernet, which would be bus and star. Again, we're leaving mesh out on that. So bus and star are both Ethernet, CSMACD. What uses beaconing? Token ring. What uses terminators? Bus. Passive clients? Bus and star. Active client? Ring. Most wire, short of mesh. Most wire is star. Least wire, bus. Handles traffic the best, ring. Star does not, because star still has that 50, that drop off at 50 machines where it goes down. So even in star Ethernet, we still have that 50 machine drop off where my capacity, actually it didn't drop off as precipitously as that, but and I said we use switches to reduce the collision domains, and that takes care of that, but it still is an issue. So capacity-wise, ring actually has the best capacity. Ring has the best capacity, but because it's fairly hard to troubleshoot, and because a single break takes the whole network down, it actually doesn't get used very much, and this break in the wire takes one client down, and it's easiest to troubleshoot. Probably the best things, and even though it uses the most wire, again, wire is one of the cheapest things in the entire equation. Oh, and I've got passive clients. We talked about the clients don't care. The hub is usually active. Actually, the hub or switch is always active because it repeats. So anything that's active repeats a message and passes it along. And we know that in the example we had that our device in the middle actually repeated everything and sent it out. Okay. So that is the end of topologies. Normally we would have a quiz. Probably by the time you're watching this will be something posted, and I'll give you questions like that where you have to look up, and we'll see. This is the first time I've done this section. We did the last half of the class online, but I didn't do the first half, so I'm still trying to figure out how to ask you questions and do things. So there'll be some type of quiz that you'll have to answer questions based on these. And these topologies will keep coming up. Realistically, they're going to be more logical than they are physical, but yeah, they'll still keep popping up. Okay, talk to you next time.